Hi all. Today we are going to learn about Ohm's law. This is one of the fundamental law in electrical engineering, and to be an design engineer, you really need to be master in this law. So, what this law says: the current flowing through a conductor between 2 points is directly proportional to the potential difference across the 2 points, provided the temperature and other physical conditions remain constant. Now, this is what exactly the word to word law, and you need to understand the meaning of every word here. If you are like talking to some really good electrical engineer, then he will definitely ask you questions like, what is this temperature condition and other physical condition means. Now, you may or may not know that for non-linear circuits, Ohm's law is not applicable. For example, the solid state network, diode, triode, or IGBT, all semiconductor devices, the Ohm's law is not applicable. Thing is that you may seen even in your career that many people really don't understand this. And if you ask what is Ohm's law, they will simply say it is V equal to IR. But my understanding is, if you really want to be a good engineer, you need to understand this law in and out. So the first thing is, this law is applicable for a linear circuit. Now, second thing is, this law is applicable when the temperature remains constant. Why? Because the resistance varies with temperature. So I'll come to this point, what is resistance and how it varies. So what is trying to say is that, let me take me this pen. Let's say this is a circuit, and this is your voltage supply. So this is the voltage, this is the resistance, and this is the current flowing through this circuit. What it is trying to say is that, when if you increase the voltage, the current will increase, right? And this will happen when the resistance, this resistance will remain constant. That is what it is trying to say. Now, when the resistance will remain constant, when there is temperature is constant. Now, what is the relation with temperature and resistance? If the temperature increases, the resistance will also increase. If this happens, then this equation will not remain valid. That is what it is trying to say. Now, let me also want to tell, I want to tell you this. This V is proportional to I, means voltage is proportional to current. If you increase the voltage, the current will increase. And this R, okay, this V will not be here. So it is here by mistake. So this R is called constant of proportionality. You also need to understand that in physics, whatever is called this constant of proportionality is something unknown. So now, because of the development in the science, we know what is resistance. It is something which causes the uh, flow of electrons. It stops the flow of electrons. That is resistance. So it can be like one of the most important parameter which stops the flow of electron is temperature. uh, because when the temperature increases, the vibration of the electrons increases, and that is the reason why uh, the flow reduces. Now, this V equal to IR formula, where V equal to V is potential difference, I is current, and R is called resistance of the conductor, which is also the constant of proportionality, which defines a parameter as resistance. Let us not enter into more detail of the theory, and just try to understand what is the implication of this in terms of design engineering. Now, in case of design engineering, you need to find out the uh, voltage drop of different, I mean, the endpoint voltage of different equipment. Like, for example, there is a let's say this is a single phase wire, and this is a 240-volt supply, and you want to know how much would be the voltage here. So that is important because the load that you are going to connect here, it may have a voltage fluctuation variation rate, maybe 5% or maybe maximum 10%. It means the voltage drop 240, 10% of 240, it becomes 24 volt. So 240 minus 24 volt, it becomes 216 volt, right? So any voltage below 216 volt here, if any voltage below 260 volt, if you get here, then this load will not work. So we need to know what is the voltage drop here. So the formula for this single phase system, this is a single phase system. The formula for this single phase system is 2 into I into R. That is the voltage drop. VD VD equal to 2 into IR. So voltage drop, this receiving end voltage VR will become VR equal to VD minus 2 into, sorry, it is not VD, it is like VS, the source voltage, minus 2 into I into R, right? This actually, this called source voltage, and this is the receiving end voltage. So that is the formula. And look at it, what is this I into R? This is nothing but the Ohm's law. So that is what it is used. One more application is that when we are using three phase circuit, so the same thing, we have some source voltage, and then you will have, let's say there is a motor with delta connected winding. This is the delta connection. If you know, it is good. If you don't know, we will cover it. So let's say this is a delta connected motor, and this is the V line voltage of VSL. This is the line voltage, and we want to know what is the VRS, receiving end voltage. The formula for this is root 3 I Z. So Z is the impedance. What is this? This is VD, voltage drop. So what will be VRL? VRL equal to VSL minus root 3 IZ. So that is the formula. So obviously it is not going to be that simple. We will cover when we'll discuss about cable schedule and cable sizing calculation. This portion, look at it. Z is nothing but it's a combination of R and L. So what is Z? Z equal to R plus JL. Right. So b- it has resistance and this inductance also, because in the cable it is not only resistance, it also have inductance. But let's consider this L is 0 for now. So Z equal to R. So what it is? It is I into R. It means again it is the Ohm's law. So that is why Ohm's law is very important to understand. Uh, in the design engineering, you will see lot of different application of Ohm's law in a different hidden format. That's all. Thank you.